Hello everyone. So today we had Google Kickstart round E and I was able to solve three problems. So today I will be discussing the solution to the problems. I hope you have read the problems. So I will just give a brief overview of the problems and jump with the solutions. So the first problem is was like we have two players, A and B, and both are playing a game. So we have some n blocks initially. So like we have some n blocks. So what player and all of them are initially colored white. So what player one does is it colors the first block which as red. So it colors this as red. Then the other player colors the other block red. But the condition is we can just color the block as red only and only if the adjacent two block if exists are in white color. So here, if we have to color the next block, it would be this one because both the adjacent has to be white and next this one. But the game is not that simple. The game is like the first player always colors the valid block, which it can color possibly. But the player B colors such in such a way that the player A has to minimum the number of blocks that it has to color should be minimum. So what does this mean is, so initially if the player A colors this box, then player B will color in a way such that in the next move player A might color have very the number of blocks it can color are very less. So here in this case it would color either this. So let's say the player B colors this, then A could color this. So we need to find the number of blocks A could color. Uh, Assuming that both of them play optimally. So the solution is very simple. So A colors the first block, then B would color the fourth block actually. So why fourth block? Because if B colors fourth block, then A would neither able to color this one nor this one because the adjacents aren't white. So let us have some more blocks here. Uh, 4, 5. Let us have like 10 blocks. I hope we can get to the approach. Yeah. So now the red would find the first block it can color. So red would color this, and then again green would color some block such that red cannot color anymore. So red would color like after two blocks. So we can just do a stimulation like color the first block, then skip two blocks. Green colors the block, skip the block. Red colors the block, and so on and so forth. So find the number of blocks red can color. Other way you can observe this the number of blocks given n blocks the number of blocks red can color is n by 5 actually the seal of n by 5. Why is this? Because let us group them in a group of 5. So we know that we can see that from every starting point of a group of 5 is colored by red. So you can just print out n by 5, the seal value of n by 5. Also we know that the seal value of n by x is nothing but n plus x minus 1 by x. So the answer would nothing but be but n plus x minus 1 by x, where x is 5, which is so value is n by n plus 4 by 5. So just print out n plus 4 by 5 and it's accepted. So that's the solution for this problem. Well, the next problem is we are given some students and each student wants to have a mentor. Uh, so each student is associated a rating. The way we can choose a mentor for a given person student is such that the rating of the mentor is not greater than 2 times of rating of the student. So suppose we are given some students. Let us have some students, and now let us say that the student X wants to have its mentor. So the mentor of X cannot be the person whose rating is more than 2 times of this 2 times of X. So let us say this person have rating some 2 times of x or some value greater. So x can only have mentors whose rating is less, so they all can be the mentor of this person. Also, mentor cannot student cannot be mentor of himself, so this person so he can this cannot be the answer. So now the student tries to maximize. Also, student wants to have a mentor whose rating is maximum in the given condition. So for this student, this person is the mentor. So we just need to find who would be the mentor for the given person, or if the mentor doesn't exist, we just print -1. So that's the whole problem. Uh, let's just see the test case. So for this person, you can see that uh, he's the mentor for this person again. He's the mentor, and for this person also he's the mentor. So what we can do is for every person x, let us have all the ratings in sorted array. Then for every person x, who could be the mentor is first we found the lower bound actually. So lower bound of 2 times x, which would give me the first element which would be greater than 2 times x or equal to 2 times x. So we got a pointer here. Now if this pointer is at the end of the array, we just decrement our pointer, and then we have to just have a several checks to find the answer. Let us just have a look at code, and I'll just explain on the fly. So we just sort all the ratings, and we find the lower bound for 2 times of area I for that person. Now if it's at the end, we just decrement our pointer. Again, if the pointer is at 2 times x rating, then also we don't want it, because we need mentor whose rating is strictly less than 2 times of the student. So we decrement the pointer again. uh, Now, if the person rating is actually RAI, which means that this person cannot be the mentor of himself, so we need to decrement our x again. But before that, we check that if it's the beginning of array, which means that we don't have any mentor left, which means no one can mentor the current student. We just put a -1. Else we decrement our pointer, and then the value at the pointer would be the mentor of the current student. If that's not the case, we already have a mentor, we just push the value into the answer, and then we just print the value. So that was the problem B. Problem C is, this was a good problem actually. So what the problem says is, we are given a palindromic string P of length n, and we need to find the shortest non-empty palindromic string Q, such that when P is concatenated with Q, P and Q, PQ is also a palindrome. So what does this say is, so suppose we have a palindrome string C D C C D C. Now we need to find the smallest substring that needs to be attached to into the front, such that this string is also a palindrome, and also the resulting string is also a palindrome. So we need to add the smallest non-empty substring in the front. The observation here is, let us so if this has to be a palindrome, then the characters in this string actually are to be the character from this string. So for us palindrome, we know that the first character and the last character are the same, and then the middle ones, and so on and so forth. So we just you can just try adding the values, so the character. So if I add C here, which means that now this string isn't a palindrome. Now I try adding D, it still isn't a palindrome. Then I try adding C. Now we can see that this string is also a palindrome, and complete string is also a palindrome. So we know. So the answer would be CDC in this case. So what we need to find is, we can have an observation here is, let us again have an example CDC and CDC. So what actually we are finding is, we are trying to find some suffix here which we will concatenate in the front. So the suffix has to be a palindrome, but also, so that the whole string is a palindrome, We know that this part is a palindrome, this part is a palindrome. Then to make sure that the whole string is a palindrome, the inner part must be a palindrome as well. So the problem reduces to given a string, we are given some string. We need to find the smallest prefix from this string such that this is a palindrome. The suffix is a palindrome as well as the prefix is the palindrome. So we need to find the first location I from the last position such that these conditions are satisfied. So the first subtask is around 10 is part 3. What we can do is we can just stimulate every string from the last position and check if this is a substring as well as this is a substring. This would take n square cost. So you can just find the first location where this condition holds true. So what I did for the first case was I just pre-computed all the palindromes from length from I to j, starting from length 1, then length 2, and so on and so forth. And then just I just checked if the suffix as well as the prefix is a palindrome. If that's the case, we just find the length, that's uh, length of the substring we need to add in the front, and then we just collect the characters from the end of this length. So that was the part one, subtask one. Now what else we can do is to optimize to the subtask 2 is the idea remains pretty same. The most computation we are doing right now is in finding if the string substring is a palindrome or not. Finding the actual string just takes linear time, so we need to optimize some around where we can easily get that the substring is actually a palindrome in linear time or nearby it. So let us take example again and look what we can observe. So let us take example like CDC and X. Let us say this XYX. Consider reverse of this string. So that's actually the reverse of the string. So if we know that if this, let us say that this part is a palindrome, which is actually is. The idea is to compute the hash value of prefix as well as suffix of the array. What advantage do we get using a hash value is suppose we are trying to find the hash value of this string. So let's say the hash value is some value a. Then we can see that the hash value, we also find the hash value for prefix of this string of the reverse string. So if the two strings are equal, we compute the hash value. We are finding the hash value of this string as well. So if the two hash values are same for the suffix in this array and prefix in this array of equal length, we can say that both of the strings are equal. So in this case, we also find the hash value comes out to be a for this prefix. And now if both of the strings are equal, we can definitely, if the hash values are equal, we can definitely say that the strings are palindrome. That is because initially the string we assumed here is just the reverse of the original string. And if this, the suffix and prefix are hash values are equal, which means that the prefix is just the reverse of the suffix. And if prefix and suffix are equal and one is reverse of the other, it's just a palindrome. That's just the definition of a palindrome. So we can just find the prefix and suffix hash values. So also it doesn't really, we just don't get to the answer, we just find the prefix and suffix value having equal hash values. We also need to take care that the prefix in original as well as the suffix in the reverse string has same hash value as well. So they should also have the same hash value, because in the earlier string we considered that both of them should be palindrome, the prefix as well as suffix. So the suffix and the prefix for this string should be equal, as well as the prefix and suffix for this string should be equal as well. The way I did hash value was I calculated the rolling hash for each of the string for prefix for the original string as well as the reverse string. I can show you the code how I did it. So first I read the string. So this function gives me the computes the hash value for the string, original string. Then I reverse the string and calculate the hash value for the reverse string. The way you can check out the way of calculating hash values using modulo inverse. You can find a blog on CP algorithms for this. You can just refer this. Um, so I think they have a blog of here, or I might just give a link where I have already this course. So yeah, this is the way we calculate the hash values for some prefix of a. So we just originally calculate the hash value for the prefixes and suffixes, and whenever we require, we just subtract the hash values accordingly. So you can just find the code here to find calculate the hash values for a given string. Uh, so back to the code. So here I just calculated the hash value for the original string and then for the reverse string, and just stored the hash values in two different arrays. Now we need to find that the prefix and suffix both are uh, have equal hash values. So forward just checks the prefix, maps the prefix of the original string to the suffix of the reverse string. So if both have equal hash values, as well as the forward of this string to the backward of this string, which means um, if they both have equal hash values as well, which means we have got the first condition. So whenever we find the first condition, we just put it to the answer, and the rest is as the same as the part subtask one. So the only optimization we need to do here was to find uh, the palindromes, prefix and suffixes, such that both are palindrome in linear time. uh, I will just paste the code in the link. If you want to refer it, you can refer it. Well, then I guess that's for this video. See you in the next one.